guys! So someone gave me the idea of actually recording myself going over the answers to the notes, so I wanted to do that here. So lesson 14. Remember we talked about perpendicular bisectors. The perpendicular bisector theorem: if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So notice point X here is on the perpendicular bisector. It's perpendicular, marked by the box. Bisector, because you see it separates it into two congruent segments. So since X is on the perpendicular bisector, that means XA must equal XB. The opposite is also true. If a point is equidistant from the endpoints of a segment, so if we know ahead that XA equals XB, then we can say that it is on the perpendicular bisector. So I can then say, all right, well then XY must be the perpendicular bisector. So it must be perpendicular and must bisect it. YA must equal YB. All right, so we use those to help us. We can look at this answer here, these slides here. I think I have my tool here. Yay, I have my pen. All right. So we have the document, or I'm sorry, the image up here on the left. NM, NL. Again, notice it's perpendicular because of the box. And the two tick marks here tell us it's a bisector. So we know NP is a perpendicular bisector. So if NL equals 2.6, NM must also equal 2.6. All right. The next one on the right, again, notice we've got a perpendicular here with the box, and it's a bisector. So that means R is on the perpendicular bisector. And you can see that tells us here that 2n plus y must equal, and I drew that right over my, let me clear the screen. There we go. 2n plus 9 must equal 7n minus 18. There we go. And we can subtract 2n from both sides, get a 5n. We can add 18 to both sides, get 27. So I end up with n equaling 27/5 or 5.4. And then notice we also need to find PQ. So we can plug that into our equation. 2 times 5.4 plus 9. That gave us that answer there, 19.8. All right, let's look at the bottom one here. DE equals 20.8. And again, if I'm going too fast for you, remember you can always pause this. Come back to it if you need to. So DE equals 20.8. That's the big segment here, the whole base. DG is 36.4. EG is 36.4. So notice because DG and GE are congruent, same measurement, they're congruent, that means they're on the perpendicular bisector. So that means the base here, DF, has to be equal to FE since it bisects it. So if they have to be equal to each other, then EF is half of the whole base, and half of 20.8 is 10.4. because it was half of the base since it was on the perpendicular bisector. All right, and again, feel free to pause this video if you need to go look at your notes or fix something up. All right, so let's look at another one here. There we go, now I got the screen. All right, so lesson 15, we dealt with centroids and medians. Remember, a median goes from a vertex to the opposite midpoint. Vertex, opposite midpoint, vertex, opposite midpoint. We put all the medians together. They all intersect at one point called the centroid. And also just a reminder, the length of the median, as it states here, we had it 1/3 the length of the median, and it's snowing. Woohoo! If you go from the centroid to the midpoint, that is 1/3 of the whole median. You go from the centroid to the vertex, 2/3 of the median. So we're going to use that on slide 19 to help us here. All right, so if in triangle JKL, JE, KF, and LD are medians. So they are medians, meaning G is our centroid. If GF is 15, then KG, remember this is 1/3 of it. This would be 2/3 or twice as long. So that means that KG would have to be 30. If JG is 13, JG, that's 13, then JE, well, 1/3 of JE is GJ, so 1/3 of it is 13. JE, to solve this, I'm going to multiply by 3. JE should be 39. All right, if JL is 22, JL is 22, that's the whole bottom of the base of the triangle here. Then FL, remember F has to be a midpoint. That's the definition of a median, going from vertex to midpoint. So if JL is 22, FL must be half of that, or 11. If KE is 20, how much is KL? Again, remember E has to be a midpoint. So if KE is 20, EL is 20, KL, the whole thing, add those two together, you get 40. All right. And again, feel free to pause these so that you can write things down in your notes if you need to. Feel free to add extra things into your notes. You can absolutely do that. All right. Find IW if FW is 10x. So FW is 10x. And IW is 2x plus 4. Well, remember you can solve this one of two ways. FW here, 10x. Remember that it is, IW is 1/3 of it. So you could say this would be 3 times 2x plus 4. Since IW is 1/3 of it, 3 of them together would equal FW, which we said is 10x. So you can do it that way. Or you could say 2x plus 4. So you could say IW is 1/3 of FW. So 2x plus 4 is 1/3 of 10x. Either way. And again, when you solve this, both should give you the same answer. 3 times 2x is 6x. 3 times 4 is 12. I subtract 6x. I end up with 4x equals 12, or x equals 3. Up here, I'm going to go ahead and multiply by 3 both sides just because I don't like fractions very much. And if I multiply by 3, it cancels out my 1/3 here. And again, I end up with the same equation down here. 10x equals 6x plus 12. So I get x equals 3, but be careful. You are trying to find IW. If I know x is 3, I can now plug that in to find IW. It'd be 2 times 3 plus 4. 6 plus 4 is 10. IW equals 10. All right. So let me clear this off here. And again, feel free to pause this if you need to finish writing things down. All right, so our last one here, mid-segment. Sorry, we have 2 more slides to go through. Mid-segments here. Remember, mid-segments connected the medians, the midpoints of each segment. So M is a midpoint, N is a midpoint. MN is a mid-segment because it's connecting 2 midpoints. And we discovered that mid-segment is half the distance or half the length of the opposite base. And if you create 3 together, put all the mid-segments in a circle, it creates a mid-segment triangle. So let's look at the top one here. We have BAC here. D and E are mid-segments. D midpoints, and they create a mid-segment. So 5x plus 6 equals 1/2 of 12x plus 8. 5x plus 6 equals 1/2 times 12 is 6x. 1/2 times 8 is 4. And if I subtract 5x, I would end up with x. I subtract a 4. I end up with x equaling 2. And I apologize. I realized I made a typo up here. This is not supposed to say DE. I'm sorry, it's supposed to say DE, not DC. So I apologize. But go ahead and put a 2 in there. 5 times 2 plus 6. That is 16. So this was supposed to be DE there. I apologize. All right. So MN NO and MO are mid-segments of the figure below. We need to find the perimeter of the whole triangle. Remember, perimeter, adding up the sides of the triangle. So, if NO is 18, that means AB must be twice that, or 36. If MO is 16, then BO must be 32. And the base at the bottom, if MN is 19, then the bottom must be twice that, or 38. And if I add those three together, 36, 32, 38, 16, 1, I want to say 106. Yay! 106. All right, and again, feel free to pause the recording if you need to. All right. Let's look at slide 21, last one here. It's a proof, so we need to put in the missing reasons. So DE and DF are midsegments of triangle ABC, and we have to prove that angle EDF is congruent to angle DFB. So we're trying to prove EDF, this angle, is congruent to DFB, that angle. And it may help if you wanted to kind of extend some of these lines out a little bit so you can really see the angle relationship that these angles are looking at here. Let me put my bottom line. There we go. Really look at those angle relationships. All right. So if we look here, DE and DF are midsegments. That is given to us right here. That is the given information. DE is parallel to BC. That's the definition of a midsegment. That the midsegment is parallel to the opposite side. So DE parallel to BC. That's the definition of a midsegment. And then if we have two parallel lines, these angles that are on alternate sides of the transversal and between the two parallel lines, those are alternate interior angles. And we know that those are congruent. All right, I hope that helps with the notes. Let me know if you have any problems or questions.